Hey guys, I had some requests for this problem from the homework, and as I think it's pretty relevant to the exam coming up, I thought I'd make a little video so that you guys would have a reference that you could look at. So this is a water hose being used to fill a large cylindrical storage tank. It's got a diameter D, and I think what's interesting about this problem is it's all symbolic. So we're gonna do everything using just variables and very few numbers, okay? So we're going to start by drawing this picture, and we have this hose, okay, and here's the ground. Oops. And so here's the hose, here's the ground, here's our water tank, and you can tell it's a water tank because it's filled with water. Okay, and we have some distances. So this is our angle, it's 45 degrees. Here we have a distance of 6D. This thing has a distance D, that's the size of our water tank, and it has a height of 2D. Okay. We know that our water starts with a velocity, which we'll call the initial velocity. And we know that there's water that sort of goes into an arc like this. But what the question's asking is that it wants the range of speeds where water will enter the tank. So that's the minimum distance and then the maximum distance. So as far as our minimum distance goes, this would be our minimum distance. And then our maximum distance, oops, not quite. Move it over. Minimum, maximum, okay? So we have some values that we know. We can write them down over here. So we know, like when we have x naught and y naught, these are both equal to 0. We know that x final, that's what we're looking for. Y final, that's going to need to be 2D. Then we know that our x and y velocities, so v initial x, is going to be v naught cosine 45. V initial y is v naught sine 45. So we can write these out as root 2 over 2 v naught and root 2 over 2 v naught. Acceleration in the x direction is 0 because it's a projectile motion problem, and that means acceleration in the y direction is negative g. So here's all the stuff we know. So here we will be looking for v initial for the maximum and minimum distances. Final. Okay, and we just need to fit it into this tank. So because this is a projectile motion problem, we usually calculate the time using the y equation. So that means delta y is equal to v naught y t minus 1/2 g t squared. And then we plug this into the x equation, v naught x t. And notice we don't have a 1/2 gt squared here because there's no acceleration in the x direction. So these are our equations that we're going to be using. Okay, and now we can just plug in. So when the water is at the minimum velocity, right, so minimum, that should be for y equals 2d and x equals 6d. Oops. And that's because that's right here, okay? So that means that's the minimum distance we need to get in the tank. The maximum distance, that's for y equals 2d, right? Because you have to get into the tank here. And x equals 7d. All right, so that's our maximum distance. Okay, so now we just have to plug in our values. So to get our time, our delta y is going to be, so we go from 0 to 6, so that's going to be negative 6d, right? We're going to use this, we're going to use this equation. So 2d is equal to root 2 over 2 v naught t minus 1/2 g t squared. Okay, this is for the minimum. Okay, so we're solving for the speed, and that means we need to also do this. So our delta x, that's going to be 6d is equal to root 2 over 2 v naught t. So we solve this for t, which is going to give us 6d root 2 over v naught, and we plug it in over here. This is going to give us a fun quadratic equation. So we have 2d is equal to root 2 over 2 v naught, 6d root 2 over v naught minus 1/2 g 6d root 2 over v naught squared. Okay, now we're going to go around and simplify this. So this is going to look like, let's find some things that cancel. These two things cancel that, this cancels with that, and this should cancel with that. So we're going to end up with 2d is equal to 6d minus g times 36 d squared over v naught squared. All right. We solve this, we get 4d is equal to 36 g d squared and that's going to get rid of one of the d's over v naught squared. So this cancels this. We get 4d equals 36 gd for v naught, which means our v naught is equal to 36 divided by 4, 3 gd. Okay, so this is our minimum v naught. Looks like this. All right, we can repeat this for the maximum, right? So looking at this, we do the same thing for the maximum. The only thing that really changes for the maximum is t is going to be equal to 7d root 2 over v naught for max, okay? Because all we've changed is this value to this value. And when we do that, we end up with 2d equals 7d minus g so this is going to be 7d squared, 7 squared d squared, so 49d squared divided by v naught squared, so we cancel the d's again. And when all is said and done, you solve for v naught and you get something like 3.13 GD for the max. Okay. So we're really just repeating the same thing we did before, but we set up a different initial value. Okay. So we know that our speeds, have a range between 3 GD to 3.13 GD square root. Okay, so anything between 3 and 3.13 as a coefficient to G times D, that's going to give us something that goes into our tank. Okay, and then next we want to think about, oh, actually that's it. That's it.